Hi everyone, Mr. Rowe here. I'm just going to do another video lesson. This is actually the last lesson in this unit, so you'll expect an assessment or assignment coming out probably on Monday. So anyways, this lesson is a bit of a hybrid. The first one, the note was empty, I filled in completely. The last one I did, the note was filled out and I talked through it. This one's a little bit of both. So a lot of it's filled out, but I left a few spots blank that I can fill out with you. So, in the last lesson, we talked about the vertex form of a parabola. So the vertex form of a parabola is this. This is the general form. Okay? Just like in grade 9 when a line was y equals mx plus b, this is the equation of a parabola in the vertex form. And this is good. We like the vertex form because it gives us lots of information. As we learned last time, these values here, the opposite of this value and this value as is, makes the vertex. If this is a positive number, this a value, then it's going to tell us it opens up. If it's negative, it's going to open down, so it tells us the direction of opening. And then that value will also help us determine the step pattern. You would multiply this number by 135 to get the step pattern. But there's also other parts of a parabola that are useful, like the zeros. So when the question asks what are the zeros of the parabola, well, if it's given to us in this vertex form, there's no way to tell. So lucky for us, there's another form of a parabola called the factored form, which is what we're focusing on today, which will help us with that. Now, if we really wanted to find the zeros of this parabola, we could just go ahead and make our graphs like we were doing in the last lesson and then just identify them. So, what does an equation in the factored form look like? Well, here's an example of one. This looks totally different than the vertex form. This is the vertex form. Look at this factored form. It's two brackets, and there's an x in each of them. So, what this wanted you to do is discover, what does this look like through investigation and table of values. So again, I've kind of modified these chosen x values to make a better looking graph. And I've taken the time and filled this out already because it would just take a long time to do it and make a recording. The video would be too long. So what do you notice? You plug in -6, -5, -4, -3, -2, -1, 0. You do all the math here. These are your y values. So -6, 5 right here. -5, 0. -4, -3. -3, -4. -2, -3. -1, 0, and 0, 5. And sure enough, look at the shape of this graph. This equation produced a graph that is a parabola. Okay, so just because it's not in the vertex form doesn't mean it's not a parabola. There's actually another form that we probably won't get to called the standard form, but there are multiple forms to look at. So what kind of connections can we make from this? So let's go ahead and answer these questions. It wants us to identify the zeros. Well, -5 and -1. And you notice I've highlighted these in red because I'm trying to get you to make a connection between the equation and the zeros. Well, what do you notice? The zeros are -5 and 1. And I won't give it away yet, but look at the equation. And I've highlighted here in the red boxes what the zeros are as well. What way does the parabola open? It opens up. The step pattern is 1, 3, 5, over 1, up 1, over 1, up 3, over 1, up 5. That's the step pattern. And the axis of symmetry is the line that goes right through the middle of the parabola, the vertex. It's the line x equals -3. So we'll do this a couple more times and see if we can make these connections. So here's another one. X minus 2, x minus 6. So again, I've kind of modified the x values to make this graph show more of what we want it to. And again, I've done all the math already, so when I plot these values from the table, I get a parabola. What are the zeros? 2 and 6. What way does this open? Up. Step pattern, over 1, up 1, over 1, up 3, over 1, up 5, 1, 3, 5 again. And the axis of symmetry, it goes right through 4. It's the line x equals 4. But what do you notice about the zeros, which are 2 and 6, and the equation of the parabola, x minus 2, x minus 6? So maybe by now you're starting to see the connection. Just to really hammer this home, we'll look at another example. So this is y equals negative this time, so there's a negative 1 in front here, x minus 3, x plus 1. So again, I've graphed this using a table of values. You will not have to do this. The idea is you make the connection between the equation and the important information that they give you, and you're able to make the graph without it. So this is just all for demonstration and for investigation. So by the time it's all graphed, it's going to look like this. Let's fill in the key information. The zeros are negative 1 and positive 3. Notice this time the parabola opens down, and we're not surprised by this because there's actually a negative 1 in front of this equation. So that has the exact same impact as it did in the vertex form. When that number is a positive, it opens up. When it's negative, it opens down. And thus, the step pattern is different this time. So instead of going over 1, up 1, we're going over 1, down 1. So that's why there's a negative 1. Over 1, down 3. And then it's off the graph, but I assure you we would have gone down 5. And then the axis symmetry is x equals 1. So do you see a connection between the zeros, which are negative 1 and positive 3, and the equation? So hopefully by now you've noticed that, these numbers are kind of showing up in the equation. Well, there's a 1 and a 3 and a negative 3, and look at that. There's a negative 1 and a positive 3. What happened up here? It's x minus 2, x minus 6, and the zeros were plus 2, plus 6. So if I were to ask you to make a prediction on a graph, I think you might say, well, it seems like the zeros are going to be the opposite operations of these values that show up in the factored form. And you would be correct. So what we've learned from all these table of values and all this investigation is this. If I were to give you an equation, I'm just making this up right now, x plus 5, let's say x minus 3, and I said, what do you know about this parabola? You wouldn't have to go through graphing all this. You could now conclude, okay, this is in the factored form. Therefore, I know what the zeros are. The zeros are going to be negative 5 and positive 3. So if it's in this form, it's going to tell you the zeros. And the A value, which in this case is just 1, is going to tell you the direction of opening in a step pattern, just like it did for the vertex form. So let's summarize this on the next page. So this is the general equation of the factored form, and this is kind of summarizing exactly what I just said, that the opposites of these values are the zeros. Well, that's great. You can look at an equation like the one we just did and identify the zeros, but how's that going to help you get the vertex? So I'm going to kind of go through that process, and this is the last skill that we need to do this lesson. Because when we had the vertex form, all we needed was the vertex and the step pattern. But if we just know the zeros, how do we get to this very important part right here, the vertex? And I'll explain that right now. So if I'm given this equation right here, this is the equation of that we want to graph. Well, based on what we've just learned through these investigations, we know that the zeros are the opposites of these. So that's why I have a 0 at minus 3 and positive 1. So I want the vertex. Well, I know that the vertex is going to occur right in the middle of the zeros. So I need to find out, well, what's the middle value between these two zeros? Now, because I have this graph, this one's kind of trivial because you can just see from inspection that it's going to be at x equals minus 1. But if in case you weren't sure, or you couldn't just do it by inspection, how do you find the middle of two numbers? Well, you would average them. If I wanted to know the middle number between 10 and 20, we know it's 15, but how could I get it mathematically? I would take 10 plus 20 and average it, divide it by 2. So I would get 30 divided by 2, which would equal 15. That's how you get the middle of two numbers. So if I want the middle value between these two zeros, which I know is part of the vertex, I average the zeros, and that's why this process that I'm describing is called averaging the zeros. So just to verify here, look, I'm taking the 0, negative 3, I'm adding it to the other 0, which is 1, and dividing it by 2. You get negative 2 over 2, which is negative 1. So I now know the axes of symmetry. Well, that's great. So how am I going to get the vertex now? Well, if I know that the vertex occurs when x equals negative 1, I just need to sub the negative 1, x equals negative 1, into the equation and find the y value. So that's what you see me doing here, and it's all written out here. Substitute the value of the axis of symmetry into the factored form. So I want to know, like this equation is telling me all the y values for any x value that I'm interested in. Well, I'm really interested to know what does y equal when x equals negative 1. So I've gone ahead and subbed in negative 1, and then I solved. So I get negative 1 plus 3 is 2, negative 1 minus 1 is negative 2, 2 times negative 2 is negative 4, and this is the y-coordinate of the vertex. So what this is telling me is that when x equals negative 1, y equals negative 4. So that's why the vertex is that point, negative 1, negative 4. So what I'm going to do is I'm going to go through a couple of examples with you. So again, this is going quickly, and again, I don't mind the pace because it's a video. You can always pause it, watch it again, work through something, go back, listen to it over and over, whatever you need to do. I am going to try to keep it as quick as possible, but on this next page or two, I'm really going to focus in on what you need to know how to do. So here's some examples. So for the factored form, here it is. So first of all, you need to see an equation of a parabola or a quadratic like this, and know that it's in factored form. Know the difference between this new factored form that we just learned today and the vertex form from the last lesson. So this is your thought process. You see this and you say, oh, this is in factored form. I know this because I see the two brackets with the x values here with numbers added and subtracted. Because it's in factored form, I now know what the zeros are. The zeros are going to be the opposite of these numbers, 4 and negative 6. What's the step pattern? Well, the original step pattern is 1, 3, 5. But my a value is 2, so I'm just going to multiply all these by 2. So the step pattern is going to be 2, 6, and 10. So whatever number is in front here, the a value, you multiply it by the step pattern, the original 1, 3, 5, to get your new step pattern. Now, how do I get the axes of symmetry? Well, I need to average these zeros. I need to find the middle. If I was making a rough sketch right now, and this is very rough, I would have negative 1, 2, 3, 4, 5, 6. Here's one of my zeros. And the other one's at 1, 2, 3, 4. There's the other one. This one's not as obvious. Like, where's the middle? I'm going to average these to find the middle. So negative 6 plus 4. I'm going to add the zeros and divide by 2. So I get negative 2 over 2, negative 1. So I know again, and it's just coincidence, but the axis of symmetry, the middle value is right here. So that's good. So I know my vertex is on here somewhere. I just don't know where. So to figure out that last piece, where's the vertex, I'm going to sub this value into my equation. So what is the value of y when x equals negative 1? I'm going to go ahead and go, it's going to be negative 5 times 5. So it's going to be negative 25 times 2. It's going to be negative 50. It's going to be way off my graph, but again, this is just a rough sketch. I can just go ahead and say, hey, this is negative 50. And my vertex will be right there on the axis of symmetry. And it'll look like this. So that is the graph of the parabola y equals 2x minus 4x plus 6. So that's what you have to be able to do. So we'll go through this. I'll go through an example of this. This note will be posted. I'll go back and make it a little neater and then post it in your notes. But you should be able to get all this information relatively easily from this equation. So it's in the factored form. Therefore, I know the zeros are going to be the opposites. So it's going to be 3 and negative 5. This parabola is going to open up because this is a positive number. The axis of symmetry is going to be in the middle of these numbers. So it's negative 5. I'm going to add those up. Add up those zeros and divide by 2. It's going to be negative 2 over 2. And again, it's just a coincidence that this always seems to be negative 1. It's going to be the line x equals negative 1. And then the step pattern is going to be 1, 3, 5. But I'm going to multiply it by 3. So 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. And the last example I'll go through with you. So I'll have this completed. You can work through this on your own, and then I'll have the answer there for you. We'll do this one, which is actually this example right here. It wants us to find the vertex of this. So again, you need to be able to look at this and say, okay, this is in factored form. Therefore, I know that the zeros are the opposites of these numbers, which are negative 2, negative 6. Great. Now I need the vertex. That's what the question is asking for. So I'm going to average those zeros to find the axis of symmetry. So negative 2 plus negative 6, divide by 2, get negative 8 over 2, which equals negative 4. And again, we have a graph here, and we can kind of see with the inspection that it is negative 4. Let's see, right? I guess I wanted that to be a straight line, but I guess not good enough for now. So now I need the y value. Well, I know that the vertex is going to be on here. I just need to know where. So what is the y value when x equals negative 4? So I'm just going to put in x equals negative 4 into this equation. What does y equal? I guess I should get it off this dotted line. Y equals negative 4 plus 2 negative 4 plus 6. So you get negative 2 times positive 2, which equals positive 4. 2 times negative 2 is negative 2, times negative 1 is positive 4. So there's the y value. And then you'll just go ahead and try to draw your parabola. And there you have it. So this example, if you can do this, then you've learned what you needed to learn for this lesson. So again, this is the last lesson of the unit. I think you'll see some practice problems and perhaps a practice test. I don't have your workbook in front of me, so I don't recall exactly what I put in there, but there's probably a review in there for sure. So you're going to work on that. Just know these materials, and I'll probably have an assignment posted for you on Monday to work on. But again, if there's any questions or concerns, don't hesitate to send me a message or an email. So your homework to practice this is 1 to 3 on this page here. Take care.